Welcome to 50th lecture in the course of Industrial Engineering and Operations Research, and we have been discussing in this week about the project management, and we told two powerful techniques. One is the critical path method CPM, other is the PERT program evaluation and review technique. What is the difference between these two techniques? CPM uses deterministic time estimates and PERT uses basically the probabilistic estimate. Otherwise, both are the part of network analysis. Okay, we make a network diagram and we decide that how the thing should be done. Today, I am going to talk about project crashing. Recently, you have heard some very bad news about the aircraft crash, but here we do not mean that project crash does not mean that the project has failed. Here it is used in a different sense, like we say crash course. Crash course means it is not that I am going to crash or destroy the course, but rather it means that whatever I am teaching maybe in one semester, I will teach in maybe 2 weeks, then it is called, it is a crash course. Similarly, project crashing means suppose there is some project in the normal pace, it will take 2 years time, but your minister wants that it should be completed in 1.5 years. What can be done? What can I put some extra resources so that it can be expedited? Can I put more manpower in some activity? These issues we are going to discuss. So, little bit subjective in nature, not much mathematics, but which is very important. Engineer should be not only aware about the mathematical tools and mathematics, but should have lot of common sense and lot of understanding. This is very important topic, and you can imply in your day to day life also, because you keep doing basically various projects may not be given by some funding agency or something. You do your own project. Say for example, you want to make one house for yourself, that is your project, and you have activities, what you have to do that. This type of thing you are going to discuss. So, project crashing means while managing a project, a manager may face either or both of the following situation. One thing, that the project is behind schedule. Okay. This is very common most of the time. In fact, here we find out that in our country maybe 80% times projects are running behind the schedule, and the scheduled project completion time has been moved forward. Or suppose you scheduled it that okay, this project has to be completed by July 15th, but then someone wants that it should be finished by June 30th only. So, in either situation, some or all of the remaining activities need to be speeded up. Whatever has been done, that is done. Those activities you cannot do anything, but other activities can be added. So, by adding resources to finish the project by the desired due date. So, we have to finish it by desired due date. So, we can add extra resources. Resources means extra money, extra manpower, whatever can be done. The process by which we shorten the duration of a project in the cheapest manner possible is called project crashing. Okay. So, in the cheapest manner, what we can do that, and we can shorten the duration of the project, that is called project crashing. So, if after baselining the scheduled duration of critical path activities, that means you make some proper reference, the planned completion of the project misses the due date set by the customer, an alternative plan must be put in place to meet the market entry requirement. Suppose you made a network diagram, and by making the network diagram like this, then finally you said that okay, this is 1, 2, 3, 4, this project has to be completed, and you say, let us say total time came out to be 20 weeks. But then you saw that your customer wanted it only in 18 weeks. So, then you have to do something to crash the project. So, one technique that can be employed to shorten or crash the project is to increase the number of personnel in selected activities. Okay. So, we can increase the some selected activities. Suppose some activity is taking place 10 days, maybe and it is done by 2 workers. If I put 4 workers, maybe it can be done in 5 days. Unfortunately, adding up to twice the personnel will not have the duration, because there is no linear relation. There are an optimum number of personnel who can be assigned to complete an activity. It has to be optimum. So, this is shown graphically here. Suppose I am showing this type of curve. This is number of person, this is project completion time. So, there is some minimum number of personnel are required. Suppose you take P minimum, that means it will take too much time, or something that, suppose if you take it asymptotically keeps decreasing at a very slow this one. So, probably it will show that if you want to finish in infinite time, then of course that you can have 0 personnel, but otherwise it becomes, shape becomes like this. And then, but what happens that there is a zone that of course there is, suppose this is P optimal, here it is, and this is corresponding time is T minimum. If the number of persons reduces in the project, then time will keep increasing, okay, and that increase in time may be in non-linear way. And suppose you increase the persons beyond P optimal, then in fact then also the time will increase, because those extra persons, they are not going to help the project, rather they will create hindrance. It is something like that, that suppose in cricket you are playing the cricket, and suppose there is a batsman and there is a that other person also who runs there, okay, that other side 2 persons are playing the ball, but there are 11 players who are doing the fielding. So, fielding means that if ball comes on any side, then you know it can be catch. So, therefore, he will put the persons appropriately, that captain. By the way, suppose you say that instead of 11 persons, you can put 12 fielders, then maybe okay, time fielding will be even more strong, because you know that this will be this one. But suppose it is said that instead of 22, that if you put say 2000 persons, then you can imagine that fielding will be proper or not, because those 2000 people, that means okay, ball, there is no place for ball to go, but they will not be able to do fielding, because they will collide with each other and they will not be able to take the ball in their hand and hit the wicket, because you know there is no this one. So, naturally this is an example. So, same thing happens in the project also, that if you know in a course, suppose you imply 1 teacher is there, but if you put 2 teachers, okay, maybe they can expedite the time, but if you put 3 teachers, then there may not be any advantage, because even you know they will not be, there will not be proper coordination also. So, first of all that, so you have to imply only the optimum number of persons, and if an activity can be partitioned, project management can shorten the activity by increasing the number of appropriate personnel. Suppose some activity is there, it can be partitioned. Then you can say that yes, suppose I am writing a book and I want to reduce the time of writing the book. If I can decide that these will be the chapters, then I can write 1 chapter and my assistant, my postdoc student can write another chapter, then we can finish book in time also. But if we cannot work, suppose there is only 1 chapter, then it will be very difficult, because he will write some section and you will write another section, then it will be difficult. In there was some tunnel, I think that which was made, and there was some alignment problem, I think in Simla or somewhere, that one tunnel was going to be made. So, some people you know dug it from this side and another people dug it from the other side, and finally it did not align properly. So, finally this is the mistake, okay. So, these type of things may happen. So, therefore, activities you have to be careful that they should be broken properly. However, increasing personnel often increases the need to communicate across a great number of specialists, which may increase the actual time spent accomplishing the task. you may very well see that suppose in some meeting, if I increase the number of members, how difficult it becomes to get the quorum and how difficult it becomes to that have the common meetings, because common time finding is also very difficult. So, if the activity cannot be partitioned, additional personnel will not decrease the time of task. Suppose the two expert chefs are engaged in creating a delicious dish, how would the addition of a third reduce a customer's wait time for the dessert, because two are sufficient? Might third chef only increase conversation and conflict in the kitchen? He will say, no, do this way, this much salt is enough, this much is this one, and there will be very difficulty. Like in aircraft also, that you will put the two pilots, but suppose you put that 4 pilots in the cabin, they may not do properly, but they may create even chances of accidents may increase. So, which task to crash? So, crash an activity only if it is on the critical path, because that is critical. If it is not critical, then there is no point in crashing that. And to minimize cost, crash the activity that costs the last to shorten. Okay. That costs the least to shorten. To minimize cost, crash the activity that costs the least to shorten. For instance, if two activities A and B are on the critical path, and if adding one person to activity A will decrease its duration by 2 months, but adding one person to activity B will decrease B by 3 months, then you add one person to activity B, because if you add one person to activity B, then time will be reduced by 3 months, and since it is on critical path, then the project time will also get reduced by 3 months. But if you put it in A, then it will reduce by 2 months only. So, I am just making a flow diagram for crashing a project. First thing is that you compute the critical path that is needed, then determine which activity or activities can be crashed by 1 unit of time for minimum cost. Okay, which activity, some activities may not be able to be crashed. To crash that activity, okay, because it will require minimum cost, and you can also tabulate cost time relationship for all activities, that cost time relationship, and this process will keep going on. Okay. So, I am giving example that suppose you are doing some assembly of some diesel engine. So, diesel some automobile you are making. So, design engine, build chassis, assemble engine, install wiring, and final assembly. I just have written, it has to be very detailed. In actual project there may be about 500, 600 activities, but just I am explaining the example, and duration is 5 days, 4 days, 3 days, 2 days, these are predecessor, so that you can make the diagram. And crashing of the activity, that means crash cost per day is 400, that means if you want to reduce design time by 1 day, then you have to do that, put 400, but still there is a minimum duration. No matter how much money you put, it will take minimum 3 days. So, we say minimum duration, that is building the chassis takes 4 days, but if you pay 300, then it can be done, but at most 3, otherwise you cannot do that. Okay, because there is minimum requirement also. Suppose house is there, so there is some procedure that that say 28 days the concrete block should get hardened or something, that much time it should get. So, no matter what you do, that you have to wait that much time. Assemble engine, normally it takes 3 days, but you can do 500 extra man you can employ, then it will take 2 days. Install wiring, 200 rupees per day if you spend, then 1 day you can crash, you can do 1 day. Of course, you cannot do in 0 day. So, therefore, limit is 1 day here. Final assembly, suppose activity is 2 days, and it is a predecessor is C and D, and crash cost is 600 per day, but minimum duration of assembly is 2 days, like that. So, you can make the critical path that network diagram based on the events, and this is I am following activity on arrow style. This is 1, 2, 3, 4, and you see A 5, B, C, D. Okay. C must be done only after A, because C's predecessor is A, that I have done. Okay. C's predecessor is A, and this is B, and finally both C and D should be done. Then it is this one. So, an activity durations are given here. Naturally, that you see that this is E1 0, that means suppose forward pass, this is started at 0 time, then it took 5 say weeks, so this is 5 and 5 plus 3 8. Another path is that here 4 days, so this is 4, E3 is 4, but 4 plus 2 is 6, but here it takes 8, so therefore you take the maximum of that, this is 8, and 8 plus 4, 8 plus 4 is 12, and this is naturally you say 12 and put the backward pass, start from 12 days, suppose 12 and 4, this is 8, so this is 8, 8, 5, basically 3 and 3, 3, 0, because this is that is this one, okay, 0 was there and 0, and this is basically 8, 8 minus 2 is basically you can say 6, okay, and 6 minus 4 is this one 0, so that no problem. So, what is the critical path? Critical path is what is shown A, C and E. Why? Because you see that 0, 0 latest starting time, latest occurrence time of the event and earliest occurrence time, both are matching. So, this is 8 minus 3, so this is 5, okay. So, this is 5, okay, you have to say this is 5 only, 3 is the activity duration. So, both are matching, so this is 5, 5 and this is 8, 8 and this is. So, therefore, what is the condition that one activity is critical? First, the occurrence time, latest and earliest occurrence time of events, okay, starting event and ending event will be same. Suppose C is critical, why? Because 5, 5, this is matching, second node, this is 5, this is 5, and fourth node, latest time is 8 and earliest is also 8, and then 8 minus 5 will be the activity duration. So, critical path is this, critical path is shown in the red color. E is the earliest occurrence time of an event, L is latest occurrence time of event. The critical path of the project is 1, 2, 4, 5, okay, 1, 2, 4, 5. Total project duration is the sum of the duration of critical activities, that means 5 plus 3 plus 8, that means 12 days. Now, objective is that reduce total project duration from 12 days to 10 days. So, we must crash 2 days on the critical path only. Minimum duration is the shortest duration, because here it is 12 days, but as such that here this activity is 4 plus 2, 6 plus 4, 10 only takes, okay. So, therefore, minimum duration is the shortest duration a task can be completed, no matter how many resources are added to speed up the task. So, thus activity A can be crashed from 5 to 3 days. It is written there in the table, it was written. Activity C can be crashed from 3 to 2 days, 1 day maximum, and activity E can be crashed from 4 to 2 days, 2 days maximum. So, these are the critical activities. Can be crashed, yes, 5 to 3 days, C can be crashed, yes, 3 to 2 days, and E can be crashed, yes, 4 to 3 days, but this is crash cost per day 400, this is 500 and 600. Now, suppose maximum I can crash 2 days here, 1 day here, 2 days. So, start with the lowest cost per day on critical path, that is A 400. So, option 1 is that crash activity A by 1 day, we just pay 400, and crash activity C also by 1 day. So, it will be rupees. So, then the project will be reduced by 2 days, because 1 day A was reduced and by 1 day C was reduced, C activities time. So, therefore, total crashing cost came out to be 900, but if we crash only activity A by 2 days and do not touch C and E, then we have to pay 400 into 2 means 800. So, in this case the total crashing cost came out to be 800. So, both achieve the goal, that means 10 days project. So, crashing A by 2 days is cheaper. So, conclusion is that I must crash the project by 2 days. So, that is what that it is the goal has come. So, total duration now has become 12 minus 2 is equal to 10 days, and total crashing cost is equal to 400 into 2, that means rupees 800. So, what is that? Original duration was 12 days, new day duration is 10 days, and crashing cost is equal to 800 and activity crashed is equal to 2 days. And now you can say that if we crash the activity by 2 days, we can modify the network diagram. We can say now A takes only 3 and therefore in the forward pass this becomes 3, this becomes 3 and this becomes what, 336. So we say that this is 6, okay, this is 6. So this is 6 because this is, I am doing backward pass also, I have to modify it, but forward pass 336 and 6 plus 4 10, okay. So this will be 10 and this what happens that this is a 0 and this is 4 and then 4 and 4 to 6, okay, and 10, okay, that is fine. And then backward pass, this is 12 minus 4 8, so this is 8 minus 3 is 5 and 5 minus 8 minus 3 is, so this is 12 minus 4, okay. So 12 minus 4 is what, that now we have taken 12 minus 4, okay. So this is basically, this has come 3 plus 3 and this was 10 days, okay. Now we have to start from 10 days, not 12 days, because I have crashed it. So 10 minus 4 is 6. So this also has become 6, okay. This has become 6, okay. And 6 minus 3 is 3. So this has become 3. So this is 3. And 3 minus 3 is equal to 0. So this is okay. And this side, this is 6 backward pass, 6 days, 6 minus 2 is 4. So this is 4, okay, this is 4 and 4 minus 4 is equal to 0. So now you see that both the paths have become critical. That means even if this activity gets delayed, so activity which was non-critical, that has become critical now. So now there are in fact 2 critical paths, they are equal. That means this is also there and this is also there. So that means that you cannot afford to delay anything. So that's what that it is done. And so crashing cost 800 and activity is crashed is this one. Another example we can see that activity A is remove old furniture. Suppose you want to do some interior decoration. So remove old furniture, first you have to remove, duration is 3 days. You have to employ some people to remove that, but minimum it will still require 2 days. Beyond that it cannot be this one, otherwise you will also not be able to see that some useful thing will get removed, is it not? If you apply more labors, then it can be removed early, but since you are alone, you have to see each and everything, so your capacity is also there. It is not that you employ 10 persons and they will within fraction of hours they will remove that, but you will not be able to see that. So therefore what happens, that minimum duration is needed. Repair electric wiring, 4 days is the duration. Before that furniture should be removed, and crash cost per day is 200. Crash cost means if you want to reduce the activity by 1 day, you have to spend 200 rupees extra, and minimum duration is 2 days. Paint walls, that means it will take 3 days, and but if you imply that some extra resources, then it can be done in 2 days. Install new flooring, it will take normally 5 days, but by putting extra resources 300 rupees per day, you can do it in maybe 3 days, maybe 300 rupees per day you can pay to labor. And set up new furniture, that actually takes has to be done before this one, but the setup here that it has to be the minimum duration is 2 only, that you cannot reduce that. So a renovation company wants to reduce the project duration to 14 days. Which activities should be crashed and what will be the total additional cost? So you have to make here you see that A, B, C, D, its network diagram is very simple. It is basically you have to do everything in sequence, A, B, C, D, and you see that this is takes 3 days, this duration is 4, this is 3, 5, 2. So how much time it takes? 3, 4, 7, 7, 3, 10, 5, 15, 15 to 17, okay, is it not? 3, 4, 7, 7, 3, 10, 10, 5, 5, 15, 17. But I want to finish it in 14 days. So I have to do crashing by 3 days. And this is the critical path also. All the activities are in critical path. So critical path of the project is 1, 2, 4, 5, 6, and critical activities are A, B, C, D and E. Total project duration is equal to sum of duration of critical activities, that is 3 plus 4 plus 3 plus 5 plus 2, that means 17 days. Our objective is to reduce total project duration from 17 days to 14 days. We must crash 3 days on the critical path. So activity A can be crashed from 3 to 2 days, 1 day maximum. Activity B can be crashed from 4 to 2 days, 2 days maximum. Activity C can be crashed from 3 to 2 days, 1 day maximum. Activity D can be crashed from 5 to 3 days, 2 days maximum. And activity E can be crashed from 2 to 2 days, 0 days maximum. So we make a table type of thing. Activity A, B, C, D. Yes can be crashed, it can be crashed, it can be crashed. E cannot be crashed, although it is on critical path, but it is mentioned that it cannot be crashed. So these are the crash cost per day: 100, 200, 250, 300, and days to crash is 1, 2, 1, 2, that minimum. So start with the lowest cost per day on critical path. Activity A needs only 100 rupee per day, so crash activity A by 1 day. So this is rupees 100, and crash activity B by 2 days, that means rupees 200 into 2. So this is, it can be done only 1 day, and suppose I do it by 2 days, next cost. So it becomes 200 into 2, that means 400. So I have to spend 500. So this crash combination achieves the target with the least cost. Okay, because if I reduce it by 1 day, another one it takes 250. So therefore what happens, total duration is 14 days and total crashing cost is 100 into 1 plus 200 into 2 is equal to rupees 500. So you can see that original duration was 17 days, new duration is 14 days, and crashing cost is equal to 500 days. Activities crashed means A 1 day and B 2 days. This much you have to do, and then you can reduce the project duration from 17 days to 14 days. So this is called project crashing. Okay, thank you very much for your attention, and this finishes basically the topic on the project management. We have discussed about the critical path method, and we have discussed about the PERT method. Critical path method uses the deterministic time estimate, and PERT method uses probabilistic time estimates. And then we have discussed about the project crashing, that how by putting the extra resources you can actually reduce the project duration. Okay, so this much is for today, and then we will be coming to the next module. We will be discussing about a new topic, that is basically on queuing theory in project management. Only this much is there in your syllabus. Thank you very much for your understanding. Okay.